Hello guys, today I will teach you Dirichlet test for uniform convergence of series of functions. So here is the statement of Dirichlet test. If number first, there exists a positive real number small k such that the mod of Sn, where Sn is sum of first n term of sequence fnx, and this is bounded by k for all x belongs to closed interval AB and for all natural number. Second, if the sequence Gnx is positive and monotonic decreasing sequence converging uniformly to 0 on closed interval AB, then the series, which is product of fnx and gnx, is uniformly convergent on closed interval AB. Since proof of the Dirichlet test, since we have given the SOPs of fnx, that is first nth term of series summation fnx, is bounded by k. So for all x belongs to closed interval AB and for all n greater than a particular m, we have the mod of Sn plus Px minus Snx is less than equal to mod of Sn plus Px plus Snx, that is less than k plus k, that is 2k. Thus, the summation r is equal to n plus 1 to n plus p frx will be strictly less than 2 pi 2k for all n greater than m and p belongs to natural number. From the given fact second, that is the sequence Gnx is positive monotonic decreasing sequence of on closed interval AB. Hence by Abel's lemma, we obtain the summation r is equal to n plus 1 to n plus p frx grx mod is less than equal to 2k into gn plus 1x for all n greater than m and p belongs to natural number. Since the series sequence Gnx converges uniformly to the 0, so for any given epsilon greater than 0, there exists a positive in numbers m2 such that mod of Gnx minus 0 is strictly less than epsilon upon 2k for all n greater than equal to m2, or mod of Gnx is strictly less than epsilon upon 2k for all n greater than equal to m2. Now let m is equal to maximum of m1 comma m2, and since Gnx is positive, so from equation 3rd and 4 we obtain mod of summation r is equal to n plus 1 to n plus p frx grx will be strictly less than 2k into gnx plus 1 for all n greater than m and p belongs to natural number, and this gives us and mod gn n plus 1x is less than epsilon upon 2k. So from 5 and 6 we can say the summation frx grx is strictly less than epsilon, and which hold for all values of n greater than m and for all x belongs to closed interval AB. Hence by Cauchy general principle of uniform convergence, the series summation fnx gnx is uniformly convergent on closed interval AB. Now we will solve by using the Dirichlet test our first problem. In this problem we saw that the series summation minus 1 to the power n plus 1 whole upon n plus x square is uniformly convergent for all values of small x. Here let us assume fnx is equal to minus 1 to the power n plus 1 and gnx is equal to 1 upon n plus x square, and we know that the first n term sum of fnx will be either 1 or 0, because when n will be even number its sum will be 0, or when n will be odd number its sum will be 1. Since Snx is bounded for all n and for all x, and the sequence gnx is positive monotonic decreasing sequence, because for all x square is always positive, and that's why 1 upon n plus x square is a positive sequence, and this is also decreasing sequence, and after taking n tends to infinity it goes to 0 for all values of x. Hence all the conditions of Dirichlet test are satisfied, and therefore by Dirichlet test summation fnx gnx is a uniformly convergent series. In example 2 we will prove that summation an into n to the power minus x is uniformly convergent on closed interval ab if summation an is uniformly convergent in closed interval 0 1. We take gnx is equal to n to the power minus x, that is 1 upon n to the power x, and fnx is equal to an. So the sequence n to the power minus x is monotonic decreasing on closed interval ab, that is 1 upon n to the power x will be always less than equal to 1 upon n to the power 0, that is 1. So for all n this value is less than 1, and mod gnx is equal to n to the power minus x mod is less than equal to 1 for all natural number and for all x, that is the series sequence gnx is uniformly bounded and monotonic decreasing sequence on closed interval 0 1, and when n goes to infinity 1 upon n tends to 0. Also the series summation an is uniformly convergent on closed interval ab, so the series summation an n to the power minus x is uniformly convergent on closed interval ab.